Thanks. So hello everyone. I'm so glad to be there. R in Pharma is one of my favorite conference. So I'm super happy to be here to learn from you and to present, actually give something to you, to the community. So today we're gonna talk about our journey of integrating WebR into the TLG catalog. And don't worry if you don't know the terms, we're gonna go through this. But let me start with a few words about me. My name is Pawel, and I'm working at Roche at the Nest project. And the Nest project is doing R package development in the regulatory space, packages like R tables, Stern, and recently CARD and CARD-X. Daniel gave a very good presentation about that, so come back if you want to get familiar with those. For the exploratory, we are doing TIL, so there are many resources about the TIL, but we are doing also something else. And now I'm going to talk one of those other projects, which is called TLG Catalog. You're gonna find me on the LinkedIn, on GitHub. Actually, the presentation is already available on my GitHub, so don't worry if you cannot follow the slides. This is already publicly available. So let's go into the TLG catalog. So what is this? So TLG catalog is a comprehensive repository of tables, listings, and graphs. That's why the TLG acronym. These are used in clinical reporting, and all of those outputs are created using R packages. This is publicly available on that website. So without further ado, let's go and see this in action. So this is embedded iframe of the TLG catalog itself. So it starts with some usage instructions, how to use it. And by the way, this is the stable version. We are also using the development ones for our development purposes, but let's stay on the stable. This is being organized in 3 categories: TLGs, G for graphs. For some of your companies, sometimes you might call it as a figures, TLFs. So let's see, for instance, in tables, we have grouped in those categories, same for graphs and listings. And let's see, for instance, the demographics table. So in here, we are using many variants of the demographics table itself. This is the main output. For each of those outputs, we have underlying code. So that's for the static. We also have the interactive TIL applications. So this is the screenshot from there. And we have some reproducibility info below. If you're not familiar with those PMT codes, don't worry. There is the index page where you can say in the index category, you have the Control F. So you can do Control F and search for Kaplan-Meier plot. Go there and you see the Kaplan-Meier article with the output and the code underneath. It's pretty simple. So that's it. I'm not going to deep dive into this. I will ask you to consume on your own. This is again all public. So if you click on that icon, you will let's say it's all available on the GitHub. So next slide. So key features. As you said, this is pretty comprehensive. It consists of more than 100 outputs, and some of them are of multiple variants. So this serves as a, let's say, book of examples. So for us as a package developers, it's as important as the good code. The examples as important as the good code to create them. And this is a book of examples, so to say. This does not include any patient data. The outputs are created using dummy simulated data from random CDs data package, and this package is also open source, so you can take it and use it. We included reproducibility information about the session info, but also including log file for the RNF. So one can download this, restore it, and recreate the same output as seen on the website. And last but not least, we integrated WebAssembly both for the static and interactive. So we're gonna go into details soon. The importance of the TLG catalog, why it's so special, why it's so important, because like I said, this is a sort of reference textbook for our statisticians creating regulatory output in R. It provides the source code, so even if we try, we won't provide any possible variants. So for instance, in demographics table, you might have many different demographic criteria to be included. So that's why it's important to present the source code so one can take it and modify slightly to meet its specific requirements. It is very widely adopted in our company, and we open source it for the public of the broader R community, including you in particular. So now going into WebR, and very briefly, I won't go into details. WebR is some sort of a framework or technology that ports R to the web browser so that it is possible to execute R code from the web browser and without installation of local installation or Docker container or anything like that. So this addressed the problem of accessibility, especially if we're talking about, in our context, this is a mass of statisticians who are maybe not really familiar with R, or R is a new technology for them, and they don't know how to install the R per se, and they wanted to see it in action and experiment. So I think it's a very good technology, especially for this kind of group of users. For more information, I would redirect you to the WebR documentation and also George Stack presentation. He gave a really good presentations, and you can find some materials online. So how does it work? It communicates through the messages. So there are essentially two threads working in parallel. You have the JavaScript thread and you have a WASM worker thread. And JavaScript sends a message to the WASM worker with some R syntax, and that worker evaluates this and communicates to the JavaScript the outcomes. So yeah, this is essentially at its core. I cannot, when talking about WebR, I cannot forget about the Shiny Life. Actually, WebR is the, let's say, is the heart of Shiny Life. Shiny Life has been covered by already in our previous workshop. So if you are not familiar, I would highly recommend you to go back into this. I'm pretty sure they give a much better explanation. But in short, it eliminates again a need or requirements for the Shiny in the central server. Actually, the central server could be a static web server such as GitHub pages, and all the Shiny evaluation is executed on the client side in the browser using WebR. Again, there are tons of good materials. I would encourage you to go into the manual to see it in action. So both are having a very good integration into Quarto. As you said, as you may saw, the TLG catalog is a Quarto website, and using those two extensions, Quarto WebR and Shiny Life, it was possible to embed this quite smoothly without any overhead code. So as an example of the WebR itself, this is a toy example. We can evaluate the code. As you see, I'm in the browser. I can evaluate code here. I can evaluate a very simple code. Hello. And I'm gonna print it. Or you might see, for instance, a documentation on the head function. Right? A very simple R syntax. Actually, you might have execute something more complex, such as model fitting. And these are non-obvious calculations under the hood, and this is all working or fully functional and interactive. I can, for instance, see the definition of the fit object here. All right. And last but not least, some of the people are not aware of the existence of a pretty cool application, a REPL application. REPL stands for Read, Eval, Print, and Loop. And let's see this in action. So this is a very raw, let's say, R console. And this allows you to, again, play and play around with the, yeah, of course. I have those quarter icons here. But so this is a very, let's say, basic R syntax is all fully functional, and this is like all available from the browser. And you can also install the packages from there using library. This is actually shipped by the WebR itself. So if I call the library for the very first time, it will download the dplyr with its all dependency, and I can call dplyr filter. And I have those functions available, right? It's all good, all perfect for experiment with the packages, etc. Especially for the end users, because you can just pass this URL, which is very simple, and assuming that your package is all available from CRAN with the binaries, with the WebR binaries being built, they can actually play around with this from the browser. It's really, really nice. Okay, a few limitations. It might be actually slow, and that's somewhat expected because we won't escape from those downloads as I showed in my previous slide. So every time you call an external package, it needs to be downloaded and installed, but it is executing just once and remains throughout the session. But if you do F5, refresh the session, it will probably be requested once again. So there are some optimizations techniques under the hood, but we won't escape from the download and install steps. That's why I think for the package developers, it's important to keep the packages as small as light possible. So this is a tiny verse kind of approach to keep it small packages so that it will be very quick to download and install. Package availability. So for now, 95%, I just checked it yesterday, 95% of the CRAN packages are available, but you might encounter some of the, let's say, critical ones that are difficult to port into WebAssembly, such as CURL package. And if it's a significant dependency on your package, you might have some issues. For non-CRAN packages, you would have to be actually build your WASM binaries yourself. But luckily, you can very easily find the GitHub actions that does it. Or if your package is available via RUniverse, it's already there, so you can use the URL. And it was given for free just like that, without any further configuration. And some of the packages require some specific WebR patches, but this is very, very specific and limited. Last point I really don't want to mention, but I need to. This is somewhat a little bit not stable. I have encountered a few issues when going through the journey, but I have to also acknowledge that the maintainers are very proactive and assisted me with my issues, either by guiding what needs to be done, how to overcome this issue, or providing the fix itself. So I have to thank them. Because with their help, I can successfully implement this. So integration of the WebR into the TLG catalog. So why to do that? We wanted to make it more interactive and more accessible. As we are package developers, our end users within Roche are somehow guided into centrally managed system with the packages already pre-installed, kind of. So if we are about to ask them to try out new features, give us feedback, it was a great platform to communicate, to ask, and to communicate with the end users. And also make it more interactive in a sense. One can change the code and see the outcome. We're gonna see it in a second. It's especially noticeable and let's say making a lot of difference in the context of the application. So as you saw on the static way of presenting the apps, you need to do the screenshots, which is way worse than embedding an interactive application per se. So as a whole, it enhances usability, and we have observed quite a lot of enthusiasm internally, making it available for the training, something that we have not anticipated earlier, experimentation, and interactive data analysis as a whole. So live demo. This is our demographic table, and as you see, this is the try this out. We have done this side by side. Try this out using WebR. I'm gonna click it here and scroll down to the application here. So let me run the code. This again to get rid of this startup messages. This is the table calculated in WebR, and this is the calculated in the static way, a normal old way. Let's call it in that way. This should be identical side by side, but that version WebR allows us to make some kind of slight modifications. I won't go very deep in detail, but let me just change the label. So for instance, I will call hello are in Pharma. And I expect this to be in that particular place. Let me run it. And I'm seeing here. So this is for the end users to try out some slight or not so minor modifications to the code base to see the outcome. I can, for instance, change the encoding into all capitals, mail, and female, right? I'm gonna run it, and I'm seeing the changes here. Same goes to the TL app. Oh, it's still loading. So in the interest of time, I'm gonna skip it. We are seeing this. So as an example, we have following demographics variables, and they are being updated here. So I can maybe clear this out and present sex. But I don't have age in there. So let me go into app code and add the age. If I click rerun the app, I am seeing the age. So this is all interactive application. I can, for instance, change the filtering. And I'm having 200 observation, 200 observation. So this is all interactive within the browser on my local machine. So this is how it looks like. So few words about how it went, and then I probably need to be quick. So first of all, first question is the static versus dynamic. So WebR code chunks are not executable during the render process. So actually we don't know if it's working. And that's one of, let's say, one of the biggest challenge, at least for me. We also wanted to know if, for instance, example code does not break because of the new package version. So we decided to keep both static and dynamic using WebR. But if it's both, how to assure a good user experience? Because, for instance, the Shiny Life applications might require a lot of page width. So as a solution, we keep it side by side, as you saw on the tabs, and for Shiny Life, we embed this full width. The technical challenge is that what to do. So if we wanted to have two outputs, how to make it dry, don't repeat yourself. So we wanted to keep a single code chunk for both static and dynamic outputs. So this is probably the most technical part, and in the interest of time, unfortunately, I need to run through this. But in short, there is a hidden gem in knit package to access the code base for the other code chunks. So usually my article looks like this. I have a following two chunks, setup and the output. And the final one, the addition looks like this. And first we are reading the chunks that we wanted to read. Then we are reading its content. Then we are creating a final string, and then we are cutting this with the as is. So as an outcome, we have a single chunk like that. But we still don't want that because that includes a lot of repetitions. Here comes the short codes. So we can encapsulate some part into a separate file, and we call that file from the article itself. And we can call it multiple times so that we have encapsulated a single functionality into one file, and we are not repeating yourself. And that's actually the final state of it. So to conclude, WebR integration makes the whole web page more accessible and encourages more interaction. We have heard a lot of great feedback, and we wanted to share it with you, with some wider community. And some future directions. First of all, we need to do several CA enhancements. Let me skip through that. But if it's possible to embed that into the Quart website, why we don't have it in the package documentation itself? So for that, I would actually ask you to go there and upvote the feature request made by Hidely to integrate with the examples. This is in the core package down repo. It has been noticed, but apparently it's not there. I'm not gonna do this, but I will ask them to, or let's say encourage you to also encourage them to deliver that feature. So this is for static, but how about the Shiny Live? And that is a new product that I have actually keep wrapping up, and it's on its way to CRAN. This is a new package called Roxy Shiny Live, and this is one of the last slide of mine with some quick Roxygen, let's say quick Roxygen examples Shiny Live. You will be able to embed the Shiny Live in your package documentation. So it will look like this. It will have the examples Shiny Live section with a working application. We have implemented in the dev version of Till Modus General, Till Modus Clinical too. So please have a look at this. And with that, I think I'm done. So I'm going to thank you for having me. Maybe we don't have much time for QA, but I'm available on the Slack, so you can reach me. Thanks.
Thank you so much, Paul. As somebody who's been an enthusiast about this technology since the beginning, like you, I was soaking this all in. I learned a lot just in that short talk alone. We are a bit low on time, but I do have a question for you that I think many of us will relate with, is that it's clear how powerful this technology combination is of Shining Live with WebR and these interactive examples to really enhance that educational experience of using these reusable, code packages and whatnot. For those of us that are dealing with still a largely, I'll just be blunt, SharePoint world where a lot of the resources are documented, what do you recommend to convince stakeholders or convince others in your organization that we need to really start paying attention to WebAssembly and Shiny Live to surface this kind of technical documentation?
I think the selling point could be the ease, because it is just very, very easily to deploy. Because otherwise, what you would have to do to deploy let's say to communicate the work you are doing to the end users, you have to have a server to which you will deploy. Then this server needs to be, let's say, accessible by the end users. And that's also with the under optimistic scenario where the user will have their own R installation, but oftentimes it's not true. So there is another middleman in this picture, which is the centrally managed thing. So you can see, how long the journey is to, and how long it will take to communicate with the users. With this, you are actually allowed to send an URL, and that's it. It's tremendous speed up with the communication. And also, this I just have heard on the George Stack presentation. It's about the reproducibility. Apparently, there are different levels of reproducibility. First one being the package, let's say package version. But actually, if we go down, we can go into a system dependency. Actually, the hardware specification, and WebR covers, if I'm not mistaken, a lot, if not the whole chain of this priority. So there are definitely some selling points about the technology, and I do really believe that it's gonna, let's say, attract some attention. I hope for
Excellent.
that.
Excellent. We'll have to stop there, but thank you, Paul. We'll continue the conversation on Slack and also the chat. Thank you again for the great presentation. We invite you to join the next one.
Yep.
See you on the other
Thanks.
side.